Hi, this is Dr. Green, and we are going to start our semester with some review of pre-calculus that's essential to what we'll be doing in early chapters and through the course. So the first thing we want to look at is how to solve inequalities, quadratic and fractional inequalities. So first we'll look at the example x squared minus 4x minus 5 is less than or equal 0. And this function here is actually a parabola, and I've graphed it here. And we want to know for which x values is this quantity less than or equal to 0. Well, notice that it equals 0 here at 5 and at -1, and that it's less than 0 between -1 and 5. Well, at least that's what it looks like on the graph. So from the graph here, we're seeing x is an element of -1 to 5. However, how do we know that's not -1.1 or 4.9? It could look like it's at -1 and 5. How do we know? So we have to be able to solve this algebraically. So the first thing you do is you want to find these points where the function equals 0, because those are the points where it crosses from positive to negative or negative to positive. So we'll take x squared minus 4x minus 5 and set that equal to 0 and find those change points first. So this is a trinomial, so we can FOIL backwards here. So our first slot should be x and x. That's going to make x squared. And then we want factors of -5 that add up to -4. So -5 and +1. So now we've got a product that equals 0. So either x minus 5 is equal 0, or x plus 1 is equal 0. So add 5 to both sides here, so x equals 5, or subtract 1 from both sides, x equals -1. So it looks like -1 and 5 are the right cutoffs there. Now how do we know it's negative in the middle? How do we know we didn't graph wrong? So what we want to do here is we want to do a sign analysis of what's going on. So this number line, that is the x-axis. We've got two cutoffs on there, -1 and +5. Those are the places where the function changes from positive to negative or negative to positive. So the zeros are the only places where it can change. So what we're going to do is we're going to pick a test number in each region of the number line, and we should see a pattern of positive, negative, positive for our function if it's graphed correctly. So we're going to plug into our two factors here. So I'm going to look at our factors above the number line. So we've got x minus 5 and x plus 1. We're going to do sign analysis of the factors. And then below the line here, we're going to list the sign of the product, x minus 5 times x plus 1. So let's pick a test number from each region, because whatever happens in that region, whatever happens for that one number happens across that entire region of the number line, because these are the only places where the function can change sign. So I'm going to pick easy test numbers here. So how about -2, 0, and 6? So take -2, plug it in here for x. -2 minus 5 is negative. Plug a 0 in here for x. 0 minus 5, negative. Take the 6, plug it in here for x. 6 minus 5, positive. Do the same thing for x plus 1. So -2 in here, -2 plus 1, that's negative. Plug a 0. -2 plus 1 is -1. Plug a 0 in there, 0 plus 1, positive. And take a 6 and plug in for x. 6 plus 1 is 7, positive. So down below, we're looking at the sign of the product. So negative times negative, positive. Negative times positive, negative. And positive times positive is positive. So, and we want where that product here is less than or equal 0, which is going to be in the middle there, -1 to 5. And we include -1 and 5 because it's a less than equal. So if this was a strict less than, we'd just have parentheses. I'm just using interval notation there. So our sign analysis is agreeing with the graph.